This lecture is going to cover drawing Lewis structures when we need multiple bonds instead of just single bonds. So you'll want to make sure that you have out a periodic table because we are still going to need to do valence electron counts. So, like I said before, with a multiple bond, everything is not bonded with a single bond. So you've probably heard of these things before. So the first type of double bond that we could have is a double bond, and what this means is we have 4 electrons that are shared between 2 elements. So we're used to seeing, if I had a C, wrong thing there. If I had a C that was bonded with an H, we know that this line here, this bond, means that I have 2 electrons. Now if I had a double bond, it would look like this. This is a bad example because H will never double bond. Now I have 4. So you can see an example down here. Between the O on the left-hand side and the N, there are 4 electrons being shared. And then between the N and this O here, it's a single bond, so there's only 2 electrons being shared between them. So I can also have a triple bond, and what that means is I have 6 electrons that are being shared between 2 elements. And that's going to look very similar to the double bond, except now I'm going to have 3 lines. So in this situation here, between the carbon and the nitrogen, there is a triple bond, and that means that they are sharing 6 electrons between each other instead of just 2 like we're used to, or instead of 4 in the case of a double bond. So let's talk about when we should actually use multiple bonds, because a compound is not going to use multiple bonds unless it is necessary. So we always want to use those single bonds that we started out with first, and then if there's a problem, then we'll go into using multiple bonds to draw those Lewis structures. So that problem is going to be when you need more electrons than what you have available. So we have to do our valence electron count. If we draw our Lewis structure and we only have 10 electrons available, but in order for everything to have an octet, we need 14, then that's when we're going to start using a double bond, maybe a triple bond. So let's look here at some examples, so just so you can kind of see. A key thing here is you have to remember that the octet rule, that everything applied by besides hydrogen and helium is still going to apply in this situation. So you have to remember that everything still needs an octet. So an example that we can do here is carbon monoxide. So same thing that you're going to follow that you did before. So the first thing you want to do is write out what is my formula. So carbon monoxide is CN1O. The next thing that we want to do is add up our valence electrons. Carbon has 4, oxygen has 6, so I'm going to have a total of 10 valence electrons here. So always want to start with carbon, and we are going to bond that to an oxygen. And now we know that what we want to do is we want to go in and we want to start filling in our valence electrons. So 2, 3, 4, let's erase that one, 5, 6, and there's 7, 8 as that bond. Then 1, 2, 3, 4, 5, 6, 7, 8. So if I were to look at this, carbon has 8 around it, oxygen has 8 around it. However, now what we need to look for is how many total do I have, because I have to match this 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, if you go back up to this first bullet here, I need more electrons than I have available. I need 14, and I only have 10. So what we're going to do in this situation, after I've drawn everything with an octet, is I'm going to start erasing some of my lone pairs. So I'm going to take a lone pair off the oxygen, and I'm going to take a lone pair off the carbon. So take one off of each one, and then you're going to add a bond between them. So now let's go back and count. Because if you see, my oxygen here still has 8 valence electrons because it has 4 from this double bond here in the middle, and then it has 4 in terms of lone pairs. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this situation, I still have too many electrons. I don't have my number 10 here. So I'm going to do the same thing. I'm going to erase 2 more pairs of lone pairs, and then I'm going to add another bond between them. So what this allows you to do is keep that octet, because remember, you still have to have an octet. So now my oxygen is sharing 6 electrons with the carbon, and then each of them has a lone pair. So 6 of their electrons are shared, and then they have a lone pair to give each of them 8. So now let's go through and do an electron count again. 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have my 10 that I need. So in this situation, we needed to use a triple bond. So see why you do not want to just go straight into, let's just give everything a double bond, okay? Because you want to make sure that you're remaining to have that octet on everything. All right, let's look at a few more examples, and then as we go, you want to make sure that you're trying these as well, not just watching. So our first one is going to be O2. So we already have our formula, so the next thing we want to do is add up our electrons. So we have 6 plus 6 equals 12. So we'll go ahead and give ourselves an O and an O. And then now we'll go ahead and fill in our octet. So in this situation, if you went through and counted, the oxygen on the left has 8 electrons because it has 1 bond and 3 lone pairs. The oxygen on the right also has 1 bond and 3 lone pairs, so each of them has 8. So let's go back through and count. We have to double check, make sure that our electron count is correct. So this is why you want to always count at the beginning and count at the end. Okay, you can't just draw and leave it there. You want to remember to go back. So counting for our total, we have 2, 4, 6, 8, 10, 12, 14. So I have 14 and I need 12. I have too many. So I'm going to erase a lone pair from each one and then put a double bond between them. Now let's go back and count again. 2, 4, 6, 8, 10, 12. And there I have my 12. So what you want to remember is you're not just erasing a lone pair from one of the elements. You erase a lone pair from the 2 elements that you plan on putting that double bond or that triple bond between. All right, let's take a look at another example. CH2O. So first thing we have to do is do our electron count. So C has 4. 2 hydrogens, is 2 plus an oxygen, that's a 6, equals 12. So we want to make sure that we have 12 electrons in this situation. All right, so let's start out with, we always know we got to throw that carbon in the middle. So there's my carbon. And then we're going to branch everything off of it. I'll put an H here, an H here, and an O here. Then I'm going to go in and I'm going to fill in everything so it has an octet. So remember, hydrogens do not need any dots. Hydrogens follow the duet rule. So hydrogen is satisfied with just having a bond. Carbon and oxygen, however, both need to follow the octet rule and have 8. So I start out with 12, so I need my electron count to match that. Let's go ahead and take a look. 2, 4, 6, 8, 10, 12, 14. So I have too many in this situation. So what I want to do now is I'm going to have to start putting some multiple bonds in here. Now, one thing that you want to remember is that you will never have a double bond, a triple bond, anything other than a single bond on a hydrogen. So if you remember back at the examples we've done already, we always erased a lone pair from whatever element was going to be within our multiple bond. Since hydrogens will never have a lone pair for us to erase, we cannot give it a double bond. We cannot give it a triple bond. So make sure that you're remembering that. So the only two things that I have lone pairs on would be my carbon and my oxygen. So I'm going to erase a lone pair from my carbon. I'm going to erase a lone pair from my oxygen. And then I'm going to put a double bond between them. Now let's go back and take a look. Let's recount. We're looking for 12. 2, 4, 6, 8, 10, 12. So now I am complete. So this next one, I encourage you to try this one on your own and double check and pause the video and see how you do. So it's sulfur dioxide. So first thing I have to do is write out my formula. So once again, pause if you haven't already. Try this on your own. See how you do. SO2. So S is 6 plus 12 from the oxygen. So that's 2 times the 6. Gives me a total of 18. So once again, what's going to go in the middle in this situation is going to be the sulfur, because I only have one of it, and then I'm going to have an O and an O coming off the side here. Now fill in everything in with an octet. And then I have to go in and I need to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So in this situation, since I have 20, I know that I have too many. So what am I going to do? I'm going to erase. So I'm going to erase from a sulfur, and I'm going to erase from the oxygen. Now, it does not matter which oxygen you choose in this case, and we'll talk about why in just a second. So if you pick the one on the left, that's okay. And then I'm going to have to give myself a bond between. So remember, you want to put that bond between the two elements that you removed lone pairs from. So let's go back. Let's start counting. 2, 4, 6, 8, 10, 12, 14, 16, 18. So now everything has an octet and my electron counts are matching up. So if you did it on, let's see, on this oxygen here, if you had a double bond between this oxygen and the sulfur here, that's okay as well. And if you kept all of your lone pairs on this one, that's fine. All right, so let's do one more example. and we're going to do sulfate. So first thing I have to do, give myself an electron count, SO4 minus 2. So if I do my math on this, that's 24, 30. My math on this is going to be 32. So always want to start with whatever we have the least or the single of. If I don't have a carbon, so in this case that's my S. And I'm going to branch those O's off to the side. So go ahead and fill everything now has an octet, so let's go back and count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, which is what I want. So in this situation, do I need a multiple bond? I do not. So that's one thing you want to remember, is you always want to fill in with single bonds before you fill in multiple bonds. So you need to go back and do that electron count. Do not assume that something needs a double or even a triple bond. Don't assume that. Alright, so thinking about that SO2, where some of you may have chosen a different oxygen than I did, what that's called is resonance. So resonance occurs when the multiple bond, so in our case it was a double bond, can be placed in more than one place. So what we're going to do is we have to draw all options for that. So for the SO2, we would have wanted to draw it like this. And we would have wanted to draw this option as well. Okay. So we are going to draw a double arrow between them, and I'll show you some examples in a second as well that you can draw down. Just to show that we could go back and forth. That's what that arrow means, that I could go, that what's going to happen is it's going to resonate. It's going to switch back and forth between the double bond being on whichever oxygen it's going to be on. So one of our examples is nitrate. So I encourage you to pause the video right now and draw a Lewis structure for nitrate on your own, and then we'll look at what that resonance looks like. So I encourage you to pause here. So you should have something that looks like this, and now remember, your double bond may not be on the same O that mine is on here. And also remember, this is drawn as a trigonal planar shape, so it's not at 90 degrees. If you don't do it this way, that is just fine. Don't worry about that. But don't worry about the angles as well. So if you did yours at 90 degree angles, that is really okay. So I have my double bond here in this situation can be found between the top O and the nitrogen. However, that's not what we want. We could have also had it between the nitrogen and this O here. But we could also have it between the nitrogen and this O here. So I have to draw all three because all three are options. So you want to make sure that when you have different options for where you are putting those multiple bonds, that you are drawing all of the options, and then between those options you have arrows. Now remember that the only reason these have brackets is because this has a charge. You do not have to use brackets if it is something like O3 would be an example of something that would have resonance. So only use those brackets again in that situation where you would need to use them. So some things that you should remember: you always have to do an electron count before drawing a Lewis structure. And then let's go ahead and add in, nope, that's not what I want. I want this to say after. Before and after, because drawing it before is not enough if you don't go back and check how many after, because that after is going to be what's going to determine for us, do I need those multiple bonds? Do I have more in my Lewis structure than what I have available? Okay. And then the next thing you always want to remember is that we're still following the octet rule. So when you draw those Lewis structures to start, make sure that you are giving everything an octet. I can't say that enough, okay? So don't just assume that you know where these electrons are going, or assume that you know where the double bond is going to be. Go through and give everything single bonds and octets, and you can always go back and erase those lone pairs to give yourselves multiple bonds. So probably also smart to use pencil and not pen when drawing Lewis structures, because you're going to probably be doing a lot of erasing, even if you're doing them correct, because you're going to have to erase those lone pairs. So go ahead and give some practice problems a try, and if you have any questions, please let me know. Good luck.